Good to see you again. We're going to continue solving systems of equations, and we're going to continue using algebraic methods to do that in this video. You just learned, if you watched my previous video, how to solve systems of equations using the substitution method. Now what we're going to do is we're going to learn the elimination method, which has less reaching capability. I'll say you'll use the substitution method in your math career a lot more, but the elimination method is preferred, I think, by most people when you're solving simple linear systems of equations like we're going to be doing, and I think that you'll like it. Now, in the course of teaching you how to solve systems by the elimination method, we're going to end up taking advantage of two properties of equality that you ought to be familiar with, all right? And I want to just briefly discuss those with you. One of those properties that we're going to be utilizing is simply the addition property of equality. And the addition property of equality is simply if you have two equal values A and B, then you can add the same thing to both sides of the equation and still have equal values, right? And you're familiar with that. You can add 5 to both sides, add -7 to both sides, whatever. This is the form that this property is going to play out in as far as systems of equations go, though. Because the systems of equations will have two equations. Let's say that you know that A and B are equal and C and D are equal. Well, if that's true, then the sum A plus C has to equal B plus D. All right? In other words, if I take an equation and I add equal values to either side of the equation, then I still have two values that are equal to one another. Addition property of equality. And then another property that we're going to take advantage of quite a lot is the multiplication property of equality, which says that if you have two values A and B that are equal, then you can multiply both sides by the same constant value C, and you still have values that are equal. And where we'll see that in play is we might have an equation like 2x minus y is equal to 11, and we may decide that we want to multiply both sides of the equation by 3, for instance, and get 6x minus 3y equals 33. And since we multiplied both sides of the equation by the same value, we're still going to end up with two equal values on either side of the equation. So addition property of equality, multiplication property of equality are going to be important for us, although we might not necessarily point out that that's what we're using every time we use them. All right, let's look at some examples of solving systems of equations using the elimination method. Now, if you'll recall with the substitution method, one of the goals that we had was when we made a substitution, we tried to make it so that we would have a single equation with a single variable in it. And the elimination method relies on the same principle in that we're going to try to take these two equations that have two variables each and pare it down so that there's a single equation with a single variable. Although the method used to accomplish that is going to be a little bit different. I was talking about a couple of properties of equality a moment ago, one of those being the addition property of equality, and we're about to utilize the addition property of equality. One thing that happens in the process of using the elimination method to solve an equation is that you end up adding the quantities on both sides of the equations together. All right? So what I'm going to do is I'm going to add the left side of each of these equations together, and I'm going to add the right side of each of these equations together. When you add the left sides together, 6x plus negative 6x is 0, right? So those cancel, which is important to what we're trying to accomplish here. And negative 4y plus 8y is 4y. And then, so we've added the left sides together. Now we're going to add the right sides together. 20 plus negative 28 is negative 8. And it's guaranteed that these two new values are equal because we took this first equation and we added equal values to either side. Hopefully you can see how the addition property of equality is involved there. Even if you can't, you can see that we added the two equations together, and the result was that I ended up with a single equation with a single variable. Now, something I didn't point out yet, part of the reason that worked is because these x's were opposites of one another. And one of the things you'll always make sure to accomplish when you're trying to use the elimination method is you'll try to make sure that either the x's or y's, or whatever your variables are, that you have one of those pairs that's an opposite of one another. Okay, so that way when you add the two equations together, they cancel out. And you end up with this nice single variable equation. All right, now as soon as we get down to that single variable equation, what we can do is go ahead and divide both sides by 4, or in other words, solve for the single variable that's there, get y equals negative 2. All right, great. So we eliminated one of the variables by adding the two equations together. That's what the elimination method accomplishes for you. Now remember that you still had to find the values of two variables here, and so we found the value of y. What we're going to do to find the value of x is we're going to substitute. You never quite get away from substitution, but it's quite easy. All we're going to do is take this value for y, and we're going to substitute it back into any equation that has an x and a y. All right, it doesn't matter whether you plug it into this first one or this second one. I'm going to plug it into the second one. Why not? That equation will then become negative 6x plus 8 times negative 2 equals negative 28. And then we'll just simplify and solve. We'll have negative 6x minus 16 equals negative 28. So negative 6x equals negative 12 after adding 16 to both sides. And then that's going to give us x is equal to negative 2. And then remember that the way I want you to write your solution to a system of equations is as an ordered pair. Now, if you're using x's and y's, you don't necessarily have to write x, y, but for any other variables like p and q, you write p, comma, q equals. And then go ahead and write the corresponding values of the variables. Now I realize I just made a mistake. That's not supposed to be negative 2, is it? That's supposed to be positive 2. So we have x equals positive 2 and y equals negative 2. And remember, the reason we write it as an ordered pair is because this is the point where the graphs of these two equations would intersect one another. All right, that's using the elimination method. Let's see some more examples. All right, so here we're going to still be solving by elimination, but you're going to notice that something's a little bit different with this pair of equations compared to the last pair of equations that we worked with. Because right now, if I went ahead and tried to utilize the addition property of equality and add both sides of the equations with one another, I'm not going to get any variables to cancel out because 2r and negative 5r are not opposites, negative 7s and negative 4s are not opposites either. So here's where we're going to take advantage of the multiplication property of equality. Remember, I can multiply both sides of an equation by whatever I want to and still have the two sides be equal to one another. Now, what I would like is to create a situation in which my variables, either the r's or the s's, are opposites of one another. And I could do that by multiplying each equation by a certain value that will make either the r's or s's opposites. I'm going to choose to make the r's opposites of one another, and it didn't matter whether I tried to eliminate r's or s's. I'm just choosing r's. If for no other reason, then one's positive, one's negative right here, so it makes my multiplication choice a little bit easier. And here's what I'm going to have to think about. I want to think about what's the least common multiple for these coefficients, 2 and negative 5. 2 and negative 5 both go into 10. And what I would like then is to multiply this top equation by something so I would get a positive 10r, and this bottom equation by something that would give me a negative 10r. And I think you can see what I can do to accomplish that then. Let's say I multiply this top equation both sides by 5, and the bottom equation I multiply both sides by 2. The resulting equivalent system that I would get would be this then. Top equation would become 10r minus 35s equals, now negative 19 times 5 is negative 95. Okay, so I'll multiply both sides of the top equation by the same value 5, so I know that this expression, these two expressions are equal. And then I'm going to multiply the bottom equation, both sides of it, by 2, and that's going to give me negative 10r minus 8s equals 52. All right, and so here we have exactly what we're looking for with the elimination method. We have one set of variables that are opposites of one another. Now, another thing I haven't mentioned yet, but it's very important, we also have the r's lined up with one another, the s's lined up with one another, the equal signs lined up, and the constant values lined up. You need all the like terms lined up, including the equal signs. And once that happens, all that I just described, now we can add the two equations together. 10r plus negative 10r is going to be 0. Those are going to cancel out. and then we'll have negative 35s plus negative 8s, and that'll give us negative 43s. And then negative 95 plus 52 is negative 43. There we got down to our single equation with a single variable, and we're able to solve for that variable. We're able to see that s is equal to 1. And then we can go and substitute again. Now this time we have 4 different equations with r's and s's. We can take any of those 4 equations, replace s with 1, and we'll be able to find the value of r. I'm going to go back to the original first equation, and I'll figure out what r is there. So I'll have 2r minus 7 times 1 is equal to negative 19. So this is a minus 7. I'm going to add 7 to both sides then. Get 2r is equal to negative 19 plus 7, so negative 12. So r equals negative 6. And then I've got my solution to this system. I can say that r comma s is equal to negative 6 comma 1. Voila. Solving a system of equations by elimination where we had to utilize both the multiplication and the addition properties of equality. It's really not so bad, is it? All right, it's really nice how you get this single equation with a single variable there, and it's actually kind of faster than the substitution method. All right, we got a couple more examples to go through, so hold with me here. Let's do some more. And check out this beauty right here. Okay, there's a couple things I want you to observe here. First of all, we don't have f's or g's that are opposites of one another. But second, and more importantly for right now, we don't have all the like terms lined up. Now you might say my f's are lined up, my g's are lined up, and the constants are lined up, which is sort of true, but what's not lined up are the equal signs right here. So what I want to do first is I want to rearrange one or both of these equations so that I can get all the like terms lined up. And the easiest way for me to do that is going to be to take the second equation and let's put the g's on the left side of the equation. Now I'm going to write the equivalent system to what we have up there, and I'm not changing the first equation at all. So let me just rewrite 4f minus g equals negative 10. And then I'm going to subtract 3g from both sides of the bottom equation. I get negative 2f minus 3g is equal to 12. So very important to make sure that all your f's, your g's, your equal signs, your constants are all lined up. Now what we can do is we can try to make it so that a set of variables are opposites of one another. And we can do that pretty simply 2 different ways here. What I'm going to do this time is I'm going to choose to eliminate the g's, and that was arbitrary. I could have eliminated either one. And I'm choosing to eliminate the g's because I see that this coefficient is negative 1 and this one's negative 3. And I could easily make those coefficients opposites if I would multiply this one by a negative 3. And so I'm going to multiply, in fact, that entire top equation by negative 3, both sides of it. So another equivalent system coming up right here. That's going to make the top equation negative 12f plus 3g equals positive 30. All right, multiplied everything by negative 3. And the bottom equation remains unchanged, it turns out. And now I'm at the situation where I can go ahead and use elimination. And when I add both these equations together, the g's will cancel the way that I wanted them to. And so I'll have negative 14f equals 42. And then f is going to give me negative 3. Excellent. And then as we've been talking about, take any equation, any of these 6 equations truly, and replace f with negative 3 to find out what g is. Let's just say I go back to the original first equation here. So you see I've rewritten that equation replacing f with negative 3. And so I've got negative 12 minus g equals negative 10. Let's go ahead and add positive 12 to both sides. That'll give me the opposite of g equals 2. And then divide by negative 1. You get g equals negative 2. So we can say that f comma g is equal to negative 3, negative 2. All right. Think you've got the elimination method down. There's one more special example that I want to show you, then we'll be done. And when I say special example, I mean there's going to be a special case that occurs right here that I want you to have seen. All right, just as with the previous system, you're going to notice that not everything is lined up properly because the equal signs aren't lined up properly. The x's aren't lined up, the y's aren't lined up. We want to rewrite it so that all those things are lined up the way that they need to be. So let's go ahead and rearrange this bottom equation by bringing the x's to the left side, and we're going to put the x's first so that they line up with what's in the first equation. And let's rewrite the equivalent system then. We'll have 5x minus 8y equals 10 still up top. And then we'll have negative 5x plus 8y is equal to negative 6. So we've got everything lined up the way that we want to. And you might say, hey, great, the x's are already opposites of one another, and so we've already taken care of that part magically. Well, not magically, it just worked out that way. But maybe you also noticed, aren't the y's opposites of one another as well? It's going to happen from time to time where you're going to be able to eliminate both pairs of variables at the same time, and that's going to happen here. When we add these two equations together, both the x's and the y's are going to cancel. Now, when you add two things together and they cancel, we say they cancel because their sum is 0. So we have 0 remaining on the left side of the equation. And then we're going to add the right side to the equation together. Still 10 plus negative 6 is equal to 4. Now, if you watch my video on the substitution method, I've already kind of taught you how to treat this. When all of your variables are eliminated from the equation, you have two possibilities. Either there's an infinite number of solutions here, or because the lines are actually the same line, or there's no solutions because those lines would be parallel to one another and would never intersect. And you determine which of those is the case by whether your remaining statement after the variables cancel is true or false. And it turns out to be false that 0 is equal to 4. And whenever that remaining statement is false, it means that your system has no solutions, which is what I would write. In your mind, you're thinking that means these two lines are parallel, but what you write down is no solutions. All right, elimination method, very useful. I think you're going to enjoy using it as well. All right, guys, thanks for watching. I will see you next time. Bye.